Um, Welcome. This is amazing. 2 years ago, I stood before a crowd. Well, to be honest, a week ago, I stood before a crowd of students, but this is different. This is what I live for. You know, talking to virtual cameras and everything, you don't get to see the faces, expressions. Is this guy talking shit? Can I understand anything? This is good. Thanks for being here. I hope the next 40, 50 minutes will be helpful for your career or the next architectural decision you are going to take, or maybe a nice, cool thing you want to play around when you have free time. Today I'm going to talk about Spring Cloud Data Flow. I'm not sure how many of you heard about it. Can I see some hands? Well, it's quite known for the crowd. A note of advice, if you think or have a different opinion, anything about it, I want this session to be more interactive than the virtual sessions I'm doing last 2 years. So stop me wherever you want. My idea is not to finish my story, but to have a discussion where everybody can actually have something to take back home. So keep that in mind. So since quite a lot of you are aware of Spring Cloud Data Flow, will not be a very new story, but let me try to give you a different perspective maybe. And at the end, we can have a nice discussion about Q&A, what went good, what is your use case you're using it. Because when I actually came across this product, I found it very disappointing that this was not really, there is not much noise around it in the internet. It's a very useful and a very trendy product, to be honest, I see it. But if you search for blogs, if you search for community presence, yeah, compared to the other products in this line they have, it's not so much. So, before further ado, who am I? I'm Soham Dasgupta. I am an Indian, living here for almost 11 years, work for Capgemini. I'm a father, I'm a husband. Yeah, I do quite a lot of stuff. Love programming, love playing around with stuff, speaking, blogging, things that I found interesting. You can find me in all possible professional channels if you just search for me. That's not Taj Mahal, by the way, if you know. That's called Victoria Memorial. That's in Kolkata. That's where I'm from. And I live in a very nice city here in Utrecht. That's about me. I don't have an agenda than this. We are going to talk about Spring Cloud Data Flow. I'm going to talk about few parts of Spring Cloud Data Flow, how we can use it in different stream and batch processing application, what the platform provides for you as a complete lifecycle management for your applications which does stream and batch processing. So nothing else, nothing more. I have a small demo. I hope that works. It's a live one. I cannot test it. I could test the small parts of it, but together it will be running today, this point of time, when I run it. So demo gods should be help me. Before I go into all the details of it, this is a picture from Confluent. They're known for their solution Kafka. What is actually stream processing? It's a very big buzzword. Event sourcing, event processing, real-time data analysis. These are the buzzwords architects use mostly. But if you really drill down to it, it's actually about data coming in very fast. And you're making decision based on the data and acting it at that point of time. So in a very simple sentence, it's not a rocket science, actually. But it's also not that easy. A few years ago, this was not easier at all. Right now, we have choices in our hand. And the Spring Cloud Data Flow falls in the category which makes your choices also abstract. So the whole idea of Spring Cloud Data Flow was to give you an abstraction over what you choose about your stream processing applications. You can choose to write those stream processing applications in your Java or Spring Boot world. You can also make it a Docker container out of it, writing in any other language, Python, JavaScript, whatever. Also, it gives you the opportunity to choose which underlying message broker you want to use. You want to use Kafka, you want to use RabbitMQ, you want to go for a paid version of Google PubSub, doesn't really matter. That, in essence, gives you a very powerful tool in your hand to play around with. That, in a sense, gives you the power to decide on the architectural decisions which you need to make today, but you can also make it tomorrow. Or, in the year forward, you can also change it from Kafka to RabbitMQ, or having a Spring Boot application to a Node.js application. And that flexibility is actually what amazed me, and also disappointed me why people are not really making noise about it. So, what is actually a Spring Cloud data flow? It's in very essence 2 Spring Boot applications, which is interacting with their own database, which can be in memory or the database you choose, and you can put it anywhere. It gives you a web dashboard where you can actually model your streams, register your applications, basically control the lifecycle of all these things that you want to do with your stream and batch processing. It also gives you a shell, it gives you REST APIs, it also gives you a Java client, which I'll come back later on in this session. So, 2 of those Spring Boot applications, one is the data flow, which has a specific responsibilities when it comes to working together and making sure the stream and batch processing applications work together. So the data flow server helps you to register the applications, keeps out the history and audit reports for all those batch, and also it's responsible for deploying the batch application. On the other hand, the skipper server is mostly used for deploying the stream-based application. It also does the history of streams and auditing and everything around it. All of this can be controlled with basic authentication or OAuth 2 if you choose to. The version I'm going to show in the demo is a small Docker compose, which I'm running locally, so no authentication at all, but you can configure it as much as you want. This is, in a sense, 2 Spring Boot applications, so think of there are no limitation on this configuration you want to do about it. Yeah, I was talking, there are options of having this database along with it, like in memory, or you can actually configure whatever database you want to, because underlying it uses Hibernate and JPA, so it doesn't really matter. There are 2 types of application which Spring Cloud Data Flow actually talks about, as in a long-lived and a short-lived. The long-lived is basically which is your stream-based applications, which runs for a longer time and does the processing, does the analytics, do its job. And the short-lives are basically the batch, which normally you schedule it or you run it once and forget about it. And they're both supported by the Spring Cloud Data Flow platform itself. So this piece of text is from their documentation, talks a lot of jargon about streaming, data processing, pre-built application. But in essence, it gives you the whole life cycle of managing your applications. You can choose to have a Java application, which is basically, whichever framework you choose, or you can actually register your application as a Docker container. Then you basically model your streams, you model your tasks, and then you manage your life cycle of those streams and tasks. Deploy, undeploy, destroy, launch, schedule, whatever you can think of. And lastly but not least, gives you the opportunity to deploy it, the cloud platform you want to deploy to. Out of the box, it gives you the Kubernetes deployment support and also Cloud Foundry, but it doesn't stop there. You can also use Docker Swarm or Apache Nomad, or basically any cloud provider which supports Kubernetes in underlying architecture. Before I go into the details of the applications and how the stream is composed and blah, blah, there's a concept of data microservices. When I actually looked up about who else actually gave a talk on Spring Cloud Data Flow before, I found two videos, actually, one in Spring 1, which was around 4 or 5 years ago, and there was another person from Wipro talked about it a couple of years ago. That's it. But on those two videos, they also talked about data microservices for a longer time before getting into the concept of stream processing, batch processing, and things like that. Because the concept of data microservices is the smaller you make your services, the better for the stream modeling and the batch modeling is useful for you. So the example that I'm actually giving at the bottom of the slide, where you actually read some Twitter feeds, for example, based on your search. For example, everybody is tweeting today about hashtag JFall. So for example, if I am an NLJUG or JFall conference Twitter handler administrator, I would like to filter those tweets and retweet or like or reply to it. Normally speaking, somebody will be sitting at their laptop looking at those tweets and maybe retweeting them or liking them or replying to them. Already we have more than 1,000, 2,000 tweets came in since the morning. And if you think of this person would be busy every second of his or her hour doing that herself. What if we can design a stream which does that for us? You can also think about all these 4 parts, which is search and filter, store, and retweet, can be coded in one Spring Boot application. That's very true. I don't disagree with that fact. But how reusable it will be if you have to put in an extra step between your stream processing. Let's say you don't want to retweet, you just want to like. Or you want to filter based on sentiments. Or you want to filter based on some users. They don't want to retweet my tweet, maybe, but they want to retweet, I don't know, Sundar, who was giving a keynote. If he tweets, maybe NLJUG will jump onto it and retweet it, because he has a bigger reach than I do. I have, I think, 300 followers. Maybe he has few thousands. So maybe that kind of filtration they want to do in their stream processing. And how will they do it at runtime? They need to then change the whole application, deploy it again, run it again, then it might work. But if you actually create data microservices which does only one job, it's easier for us to design those streams which are also becoming very reusable and flexible in essence. So the data microservices concept comes from that perspective only. So it only lives in the world of stream processing where you actually think your steps, what a stream would do in a very, very nuclear level. That these are my small steps, and these I want to divide my data microservices to. They deal with data, so that's why they call data microservices. Yeah, maybe they could have chose for a better name, but it's basically a very nuclear job which helps you to define your streams in a flexible way. You can also do that by config parameters. So these are also maybe Spring Boot applications, and you can also configure them to react in a different way. You can argue about that as well. So yeah, maybe I'll control these retweet or like, or which Twitter handle I should retweet to from a config parameter basis. Yes, you can do that. I'm not saying that is good and this is best. I'm saying these are the options you need to think about when you're defining your streams. That's it. So when we talk about streams, we talk about long-lived applications. These long-lived applications, the platform manages the whole life cycle of it. And basically, when you build a long-lived application for a Spring Cloud data flow, as I was saying at the very beginning, it abstracts the message broker it works on. And that is kind of supported by the Spring Cloud Stream Binder library. This binder library gives you different dependencies to inject on. And with those dependencies, you actually can decide which underlying message broker you are communicating to. If you have worked with the Kafka library in Spring, they have specific configuration parameters which says you are actually connecting to a Kafka topic. Or you have specific objects which you are using within your code which tells that you are actually using a Kafka template or a Kafka topic. Which is good if you never want to change your Kafka broker the whole life of this application. But that doesn't give you the flexibility. That doesn't give you the choice, the architecture choice or the infra choice to make it later or abstract it from the developer perspective. What this stream library does for you is it gives you a bunch of ways to code how to interact with these topics or queues. It doesn't tell you when you're coding that you are actually connecting to a Kafka topic or a RabbitMQ queue. I will come to the way of programming this in a bit, but the essence is adding a dependency or changing a dependency would change the message broker you are actually connecting to underlying. All the properties that you need to configure where the message should go, where you should read the message from, is independent of which underlying broker you're using. So that's the whole concept of having the Spring Cloud Stream supporting Spring Cloud Data Flow. By the way, you can also use the Spring Cloud Stream without Spring Cloud Data Flow. It's a Spring Boot library anyway, so you can really create a standalone application to interact with any abstract the message broker anyway. So what is Spring Cloud Stream? It's also the first line taken from the documentation. But it actually gives you the focus on building the business logic itself. You don't care about where it is going and where it's coming from, rather than what I should do with this event or what I should do with this message at all. The Spring Cloud Data Flow gives an option of 3 types of application when you are actually registering or defining your stream. One is a source, one is a processor, and one is a sink. Source and sink is pretty understandable. That's the source of your events or messages. Sink is where you end up with the processing. And processor is where you do all your processing stuff. There is also an opportunity to read the messages from a queue directly. So you can also model that. So in my example, I'm actually reading it from a queue, not from a source. So I'm generating the message outside of the boundary of Spring Cloud Data Flow, and I'm reading in, and that's how I configured it. And you can also think about your sink as a queue where the messages ends up. It doesn't have to be an application always. You can also think of it as an analytic. So, you analyze all the things that are happening, all the tweets coming in. At the end of the day, you generate a report that this guy tweeted a lot. Maybe we should give him a beer. And it gives you 3 types of programming model: imperative, functional, and Kafka streams. Even though it says Kafka streams, it is not tied to Kafka. The way of dealing with the streams is taken over from the concept of how Kafka does it, so that's why they call it. The functional is the best way so far in my experience. It's very straightforward. It uses Java util function for consumer and what is the other one? Processor. And then you have the imperative way, which is a very annotation-driven. So you define, this is my processor, this is my sink, this is where it should go. You add enable binding stuff. So yeah, it's a lot of boilerplate code to my knowledge, at least I think. So how they look like. As I was saying, the imperative is pretty much you define on your class level and method level, where you define what is a processor, and this is an input of it, and there should be an output. Functional way is very, very straightforward. You define a function, and that always returns something. In case of consumer and a source, then it's basically you're generating or receiving it. Kafka Streams does it in a Kafka way. So if you used Kafka Stream before, so the programming style is taken over from there. By the way, the Spring Cloud Dataflow actually been designed from the perspective of how Kafka deals with streams, messages, and events. So you always have a source which puts things in a topic, separated by partitions and keys, consumed by a group of consumers based on partitions or group IDs. So Spring Cloud Dataflow also works in that way. The whole concept being taken over it from Kafka, but they abstracted it for every other message broker they could find. Stream configuration. So this is where the part comes, where I try to show the demo, which, fingers crossed, works. So the way the stream configuration happens in Spring Cloud Dataflow, this is basically the screenshot from the dashboard, the web dashboard Spring Cloud Dataflow comes with, where you basically does all this lifecycle operation with an application. You register, you create, you deploy, you do auditing, and you basically undeploy and other stuff. They give you a very drag and droppy UI where you can actually drag and drop your application, connect them, click a button, deploy them. While deploying, select a platform where you want to deploy, Kubernetes, local, whatever. Define your configuration parameters, and then it gets deployed. At the time of deployment, you also can actually say how many pods you want or how many instances you want them to run. Not only that, later on, you can update your deployment so that you can scale up or scale down. So it's not really running the application, but managing at the runtime as well. So if you're doing this, you don't need to really rely on your Kubernetes at all. Well, a bit, but not really on the deployment level. So let's see. So I have a bunch of applications there. Only 3 of them I coded. The rest comes packaged with the Docker Compose that I'm using. You can switch that up as well. But as you see, there are different source, processors, and sinks. And there's also another type, which is task, which will be used for the task processing. You register the application. There are different ways to do it. You can link it to a Maven repository, which is running somewhere remote. You can also use a file mapping. So if you actually mount your local drive to your Dataflow server, then you can read the file directly. You can also use a Docker hub somewhere which connects and reads the Docker container image. I'm not going to register the applications because I've already done that. It's a very simple UI. You select where it is, what is the name, what is the type of it, and it's done. Simple. Also, creating the streams. So basically, it gives you an editor where you can drag and drop your source. So for example, this is an HTTP application, which, if I send something, will log something. And you connect them, and that's your stream. That's simple as it, basically. But that's not what I'm going to show, because that you can find in the documentation. What I'm going to show is the stream that I created, that I was talking about. Actually, let me talk about it a bit. So it's a stream starts with a destination. The destination is what I was talking about. You can start your stream also from a topic or a queue. So your whole stream processing starts from a queue. What I did is, in my application, I externalized a Spring Boot application, which I invoke as a REST API, which does the search and put all the results in a queue. And then that's where my stream processing starts. It reads from the queue. It filters on the sentiment. So I used a Stanford NLP library to check whether it's a positive, neutral, or a very bad tweet. That's configurable, by the way. So you can set from 0 to 5, the sentiment, 5 being very positive and 0 being very negative. And then you store it to find out whether you already retweeted it or not. And if you have a unique tweet coming in, you pass it on to the retweet app, and it retweets it for you. That's the whole idea. Simple, eh? But I don't know whether it will work. So when you try to deploy this, by the way, all these features that I'm trying to show with the web dashboard is available via Shell, so as a CLI, available via REST API, and also available as a Java client. So you can write your own Java application to do all of this, which happens in the web dashboard. So what you do have to select a platform. By my case, it's a local platform. And here is where you define your deployment level properties and application level properties. Some of them are already filled up because by default it uses the Zookeeper. By default it uses a Kafka broker, which is already part of this Docker Compose file. But yeah, you get the idea. You can change whatever you want to do it. Now, the Twitter read application, which I said I externalized it. So if you see the application, it actually has a specific topic where it sends all the tweets to, which is Twitter feeds. And if you remember, that's where my stream starts. So once it starts, I can actually also access the logs. I can also access the history, how many ever times it has been deployed or not. So I tried deploying at 1 o'clock, but due to internet problem, I could not test it. So that's the only time I could deploy this. So this is the externalized Spring Boot application, which exposes a REST API, where I say which hashtag it needs to search for and how many results it should pull out. So it does a top, so it uses a default. By the way, if I'm going to share this code later on, I use an archived Twitter library from Spring Boot, so my apologies. You can use a better Twitter library to do this. But I wanted to find a very quick, easy, dirty solution for my demo, so that's why I picked it. But anyway, it reads things from the tweet, and it sends it, yeah. Maybe it's a. I also have a control center running, not Corona test. So once you deploy it, so these are my previous attempts of testing the part of those applications that I was saying. So once you deploy it, it creates the topics for the applications itself. Well, you can choose to have the topics already created, but Spring Cloud Dataflow doesn't exist, it creates it for you. The first part is the name of the stream, and the second part is which queue it is going to. So I did a search, and I saw these many tweets are coming in. So I hope things are okay. So let's see. I should see some messages coming in if things goes all right. Cool. Things are coming in. Hold on. It still needs to retweet. If that doesn't happen, then... So let me first check if I retweeted something. And God forbid I didn't retweet something which I shouldn't be. Well, no, it didn't retweet anything. So yeah, there's something wrong. So ideally, this should filter my tweet. So if you see, I have a few log messages for checking what's going on. So if you see, it actually gets the tweet text. It analyzes the Twitter text to see how good, positive, or bad it is, gives it a rank, and if it's more than 2 or equal to 2, it goes on, actually. Am I saying this right? Yeah, the threshold is 2 I configured by default, and I didn't change during the deployment, so it is still 2. So anything equal to and over 2, oh, it has to be over 2, sorry. So it has to be over 2 to go up. Apparently, there is nothing over 2. So everything is neutral. So let me see if I stored anything. Actually, I didn't. So actually, the application works, but it didn't work at all. Let me actually do that. So let me undeploy this and deploy the stream with a different value. So it's an application property, so I'm going to do it there. And on the filter, I'm going to put 1. Fingers crossed, this time it should retweet. I have to give this a bit of a time to start up. Till that happening, anybody has questions, concerns, discussions points so far? No? Okay. Yeah?
Yeah. What about different ways to process messages? I mean, Kafka process messages like you have defined order and topics. Now RabbitMQ process messages like you get them out of order. Those are totally different ways to do it. And if you write code that is totally distant from this technology, then how can you make assumptions about your code and write?
The whole idea is not. So see, it is not going to, I'm not saying you should replace your Kafka and a RabbitMQ way of doing processing messages with Spring Cloud Dataflow. What I'm saying is, if you have an architectural need where you really don't have to go into that detail of complications, this is your guy. So if you are relying on partitions, if you are relying on how you do grouping, if you're relying on the keys, how you read your messages, you can do that with this as well, by the way. It's not a problem. So it is, I showed a linear stream. It can have multiple outputs, which is a paid version, by the way, but you can also tap into it. So you can say, I have 3 different consumers listening to 3 different keys or 3 different partitions of this queue. That is possible. There are ways to do it. I'm just showing a simple application which gives you the idea, but it is possible. But at the same time, if you want to rely or you want to build your application around Kafka, you should not be choosing Spring Cloud Dataflow then. So you are Kafka-based application, your RabbitMQ-based application. But if your sole purpose is to process messages in a streamlined way, and I also want to manage my application lifecycle, Spring Cloud Dataflow is the best choice or the freest choice you have in a message-driven way. Not.
It means you may make assumptions, but
Well, there are different use cases. Like for this, use case, I really don't really need to have those partitions or groupings or consumer at all. But if you really have messages where you decide on the fly which partition it goes to, and you have a different consumer group altogether for that partitions, you are really trying to implement a solution which is based on that concept itself. So, and there, your core is not Spring Cloud Dataflow, but your core is how Kafka, you modeled around Kafka, your architecture. So then you already chose what you want to go ahead with. So there, the question doesn't come whether you should again use Spring Cloud Dataflow to abstract that layer, because then the abstraction is of no sense at all, because your whole architecture based on Kafka itself. So you cannot just overnight change it to Rabbit. It started up. So let's try this again. Still not tweeted. If this doesn't happen, I'm going to go ahead with the presentation anyway. It stored some tweets. The retweet failed. Yeah, the retweet failed. Yeah. Yeah, sorry. You have already retweeted this tweet. So I've already retweeted this tweet. So I shouldn't have tested my modules separately. Well, yes! Yay! Okay, I have to read later on what I tweeted. Okay. Anyway, so that's a very simple example of how you can actually do a processing of tweets, which is coming in every second, every minute, however you can think about it. And you abstracted the whole process of, retweeting it at the end, defining the sentiments, control the parameters, also using the configurations. If you go into their documentation, they give you all sorts of different scenarios how you can model such streams, multi-output, single output with multiple consumers, multiple partitions, things like that. I'll leave that to your, phone. The next part is, I think I have not so much, but okay. Short-lived applications. This is the part which the Spring Cloud Dataflow gives you the task management. And that's being done by the Spring Cloud Task Framework. This is also the way of writing Spring Batch programs for your application. It's basically one short amount of time life cycle where it does something and then goes into hibernate or a destroy status. What extra you get with Spring Cloud Dataflow is you get all the logs, you get the execution status of it at the end. You can also schedule it. I cannot show that schedule because it's only possible in a Kubernetes or a Cloud Foundry environment. Locally, it's not possible. But you can think about something like you analyze and send it to analytics, the tweets that are coming in. Or the tweets you have retweeted, you actually can read it and send it back to somebody who will gonna check, let's say every 4 hours, whether this person has retweeted something which is not supposed to be. Or some kind of other analytics where you're checking in how many tweets are coming in for a JFall conference like this, so that you can actually think about what will happen if I organize it next year. And what are the things which I should concentrate on? Who is tweeting more? How many people are actually here today? Who are active, who are not? And which sessions are more crowded than the other sessions? Things like that. But the life cycle is very similar to also the stream application. So you register it, given it a type, and then you define a task using the similar Unix style approach. So pipe for sequential. You can also do the greater than and less than sign to do it parallel. So yeah, pretty much similar. I can show you an example of it, but I think, yeah, you know, in the documentation and all, they talk about the timestamp application. I wanted to actually make an application which looks at the retweets I have done and sends me something back, or given a notification that these are the tweets you have missed, or these are the tweets you have tried to retweet again, so that it gives me some data back about how good my application is doing, the stream application. But yeah, the time was not there for me to do that. Anyway, the other parts of the Spring Cloud data flow is the tooling and the API. As I said, it gives you a shell. You get to download a jar, which you can actually start using normal Java command, with all the properties that where your data flow server is running, where your skipper server is running, and that gives you ultimately a CLI. And with that CLI, you actually can do the similar stuff which you just seen in the web dashboard. The power of this is you can script this. So if you have a CI/CD pipeline which you are managing all your application lifecycle, you can use the shell basically to write a script which does everything for you. So if your application gets a new image, you register the new image. Then possibly maybe you want to update your stream and deploy it again, or run your tests. Or if you have a task-based application, if a new version is coming in, you want to also redeploy it, or create a new batch processing out of it. It also gives you the REST endpoint. So if you are not going to use that, you can also use the REST endpoint. I can show you a couple of examples. It has a whole list of things you can do with REST. So everything you see in the dashboard is, again, possible via the API. This is a small example of how many streams I have. And it gives you the whole DSL text along with what kind of config parameters and deploy parameters I used to deploy it. It paged with how many results you want. You can also create a stream from the REST endpoint itself. It uses all in the URL parameters, and if you have a stream with all pipes and everything, you need to encode it. So what you see here is basically encoded string, which I actually encoded before. So it is basically HTTP and log, which I encoded to that. And if I use it, if everything goes all right, I should see the stream back here. Look. So you can also manage this using the REST endpoints as well. The last but not least is the Java client. So whatever you, again, can do with the web dashboard, if you choose to write Java code, you can do that with one single dependency. And you can actually create your stream, deploy it, manage it, the whole life cycle basically in your Java code itself. And yeah, the three different options you can choose from, whichever is preferable for you. It also supports monitoring. So not only the monitoring of the data flow and the skipper server, it also gives you the monitoring over all the applications that you are deploying or managing via this platform. You can, it is designed around micrometers, so you actually can plug in quite a lot of monitoring tools. From the documentation, official documentation perspective, you get Prometheus, Webfront, and Influx. But actually, there is no limit, to be honest. You can actually configure whichever monitoring tool you want from it. And to get the future you want. No. Well, that was the story I had. And we have, 6 minutes for discussions, comments. Yes? I'm not allowed to talk about it. Yes. Yes, we are going to. Very large scale. And to be honest, we found out doing our research with Spring Cloud Dataflow, the way it manages the pods and spins up it can be a question mark to some resource utilization perspective. So yeah, we are still thinking about it, actually, to be honest. We see the power, but it also has some negative points, so it's not really walk on the grass, to be honest. The way it manages resources is kind of a worry for us, so we are still trying to figure out how we can manage this. So every stream gets its own pods, so the way of reusability is kind of a question mark. But it is a question mark because we still need to put on effort and research to it. Yes?
Yeah, kind of similar question to the previous one. Like, what was the actual use case for this? Because you can use Spring Clouds to build your application and hardwire it in your configuration and deploying on Google or in Kubernetes or so, and you will not. I mean, is there actual any need to reconfigure all these streams for a long-lived application in runtime? Like, this is what's bringing this dashboard provides. And if you are choosing for short-lived applications like tasks, then you are better off with Spark because you cannot fully
Sure.
fire up things, but you can actually write the stuff you want to configure into Spark.
True. I agree to that point some extent. The only powerful part I see personally from Spring Cloud Dataflow is the stream development, where you have these reusable pieces of application, and you can actually start up a stream, quite easily. If you have such kind of use case, then yes. But you are very right. There are questions also about where do I want to use it, unless I want to manage everything A to Z via Spring Cloud Dataflow. If that is your use case, then yes. But I understand your point of view. The event-driven architecture actually starts with what is handling those events and how are you handling those events, rather than a platform which is abstracting you from that perspective itself.
Because if you are starting using this, you also should consider security.
Yeah, it is there. Security is there. It's not really that it's completely outside. It's all open. It depends on how you actually configure and implement it. So by default, it supports you the basic and OAuth, but it's actually on the applications. It's the streams is consist of where you do your security part. So what data are you coming in? What data I'm allowed to listen? Which topics are allowed for which consumers? Things like that. It's a good point. Thanks. Yes.
Yeah, you'd mentioned you'd focused heavily on the stream side of things, but also with Spring Cloud Dataflow, there's also the batch processing. Can you just explain that?
I didn't really focus on it. Yes, correct. The batch processing side is, basically it provides you a bunch of task applications which you can register, which is based on the Spring Cloud Task framework. And then you organize your tasks around it, which are very short-lived, like you want to fire up once in a while, check something, do something, and goes back. Like checking your database status, or creating a table once in a while, or backing up your data every morning. Things like that, basically. I didn't focus on it because what I wanted to do is firing. See, the demo I showed is a REST API which is being fired from outside the whole context. So what I wanted to show is basically if I can schedule a task which checks every 10 minutes which all new tweets coming in and pushes in the broker. So you can think from that perspective as well. Imagination, yeah, you can free flow it, basically. But yeah, I didn't have time to configure that application. But maybe when I'm putting it in the GitHub, I'll try if I can put it, because it's a 4 lines of code maybe. Yes?
Those small services that you had for the filtering and
Yeah.
retweeting, does it always have to be written in Java, or can it be any other?
It can be any other language. When it started, it only supported Spring Boot applications, but now you can register a Docker container. So that brings you the abstraction of whichever language you choose.
Yeah, my remark over there is Spring Boot apps are first-class citizen.
Yes.
I tried Node.js and Python apps, but yeah, it's doable.
Yeah, that's one of the things also I saw. To be honest, yeah, there are limitations, I understand, but this product is also solving a specific part of the industry, which is, yeah, why people are not making use of it and why Spring is not spending time building it, because it came out around 2015 or 16, if I'm not wrong. And to be honest, in last 5 years, it didn't change that much. They had Spring Boot at the very beginning, now they support Docker container. The monitoring and tooling a little bit better. The UI looks a little bit better, but yeah. So yeah, I also in doubt, but I thought, let me share my experience about Spring Cloud Dataflow, which I worked on. Maybe it's helpful, maybe it's not, but yeah, it gives you something to keep on your head when you're thinking about applications like that. More questions, comments?
Just feels very bloated.
Yeah, I did a product session, isn't it? No, I never contributed to this project, neither am the expert of this. I don't claim it. Yeah, the project we do, I'm not allowed to share, so I had to think of a use case which I can.
It's basically orthogonal on Sander Hoogdorn's talk about it.
Yes, I'm keeping it very simple. So this is just a one line of functions with int I is equal to 1. If there are no other questions, I want to thank you all for coming in. This was nice. And thanks a lot.